Good morning. Today I am going to tell you about convex hull. So, starting with the definition, the convex hull is defined as the intersection of all the convex sets containing a given subset of Euclidean space or set of all convex combination of points in a subset, which is simply determined in a simple words like given a set of points in a plane, the convex hull of this set is the smallest convex polygon that contains all the points of it. You can see the figure. You can easily understand from this. In simple words, the combination of all the points in a given space or a Euclidean space the combination of all the points in a given space in a subset or a given space is called as the convex hull. We will introduce an operation n log h algorithm known as Chen's algorithm, where h refers the number of points in the hull. However, Chen's algorithm is based on other two algorithms known as Jarvis algorithm, operation nh, and Graham's algorithm, operation n log n. So we will talk about these two algorithms first. Before start, we will talk about the counterclockwise and clockwise, which is quite relative. In this presentation, use the function orient pqy to calculate the relation of pq and pi. Obviously, orient pqy is equals to minus orient piq. Extreme points. There will be 4 extreme points. All of them must be in hull. Lastly, most algorithms choose to start with one of the extreme points. In this presentation, all algorithms will start with the leftmost point. Jarvis algorithm. Jarvis algorithm. Perhaps the simplest algorithm for computing convex hull. In the two-dimensional case, the algorithm is known as Jarvis algorithm after R.A. Jarvis, who published it in 1973. It has more visual name, gift wrapping. How it works. Start with the leftmost point L, operation N. Let P is equals to L. Find out the point Q that appears to be the furthest to the right to someone standing at P and looking at other points by comparing all the other points. That is, orient PQI is less than 0 is always true for all other points. 3. Set Q as P and use the P as the start point and use the name method to find the next Q. Keep doing step 3 until Q is equal to L. You can see the figures. Graham's algorithm. Graham's algorithm. It is named after Ronald Graham, who published the original algorithm in 1972. Also known as Graham scan, first explicitly sorts the points and then scanning algorithm to finish building the hull. Basically sort plus scan. How it works. Start with the leftmost point L, operation N. Start sorts of all points in counterclockwise around the L. That is, orient L I plus 1 is greater than 0 is always true for all the points I. Start with the L, let P is equals to L, Q is equals to L plus 1, I is equals to L plus 2. Check orient PQI. If less than 0, move forward, let P is equals to Q and Q is equals to I and I is equals to I plus 1. If greater than 0, remove Q, let P is equals to P minus 1 and Q is equals to P. Keep doing step 4 until all the points have been checked. You can see in this figure. Chen's algorithm. Chen's algorithm is equals to Jarvis plus Graham's. It was discovered by Timothy Chen in 1993. It's a combination of divide and conquer, gift wrapping and Graham scan. It's output sensitive, which means its running time depends upon the size of its output or input. How it works. Find a magic value of m, which divides all the points into n by m subsets, and each subset has m points approximately. To each subset, use Graham's algorithm to compute its subhull. To all subhulls, use Jarvis algorithm to compute the final convex hull. Choose one extreme point as the start point and compare the right tangents of all the subhulls. Choose the rightest one as the next point. Start with the next point and do it again until the next point is equal to the start point. You can see the figure. Find magic M. The core of the chain algorithm is how to find the value of M. The object is to make M very close to the H or equal. Chen proposed an amazing trick here. We set a parameter t is equals to 1 and set M is equals to 2 की power bracket 2 की power t. Then use this M to execute chain algorithm. In step 3, we set a counter for the output number of points in the hull. Once the counter reaches value M, it terminates the algorithm and increment t by 1. Recalculate the value M and do it again. By doing this, the time for running this algorithm will be much less than operation n log M. Time complexity. Find a magic value M which divides all the points into n by m sets, and each subset has m points approximately. To each subset, use Graham algorithm to compute its subhull. To all subhull, use Jarvis algorithm to compute the final convex hull. Choose one extreme point as the start point and compare the right tangents of all the subhulls. Choose the rightest one as the next points. Start with the next point, do it again until the next point is equal to the start point. Here are these steps for doing this. For step 2, it's operation n by m into m log m is equals to operation n log m. For step 3, finding one extreme point, operation n tangents, and after finding the tangents, finding the right tangents of one subhull, operation log m. There are n by m subhulls, so operation n by m log m. There are h points in the hull, operation h into n by m log m is equals to operation n log h. Totally it's operation n log h. That's one example. Sorry, that's a chance algorithm represented in the form of figure. These are the references. Thank you. And it is an example of a gift wrapping, not chance algorithm. Thank you.